right, so I'm going to do some more practice with greatest common factors. So in this lesson, we're going to actually be factoring. So in the previous lesson, we were just going over how to find the greatest common factor. So the first thing I want to do on this problem at the top is just to go over how we find the greatest common factor. So make this a little bit bigger. Okay, so the first thing we're going to do is we're going to list our factors of 14. Now, on the graphing calculator, and I remember I sent you I posted the links to the online graphing calculators. What you can do to get your list of factors is go into the y equals and type in 14 divided by x. Okay, then you'll go into the table and you're going to start at x equals 1. Okay, and then you're going to just look and see where you have whole numbers in your table. You're going to just keep going. You're not going to write down any decimals. You're just going to write down the whole numbers. When the numbers start to repeat, so for example, with 14, the first pair of factors is 1 and 14. The next pair is 2 and 7. So that would appear in your table. Then 3, 4, 5, and 6 are all going to give you decimals in the y, so we don't want to use those. So the next one that would come would be 7, 2. But if you notice, 7 and 2 and 2 and 7 are just the same thing. So at this point, you would stop. You wouldn't keep writing, okay? So for 14, our factors are 1 and 14 and 2 and 7. Let me just erase this. Okay, now we'll do for 42. So for 42, our factors are 1 and 42, 2 and 21, 3 and 14, 6 and 7. And then our factors of 77 are 1 and 77, and 7 and 11. Okay, so right now, if we look at our three lists, let's identify what numbers our lists have in common. So, one second. Okay, so all the lists have 1, okay, and all of the lists have 7. Okay, so the greatest common factor, you're just basically picking between 1 and 7, which one is bigger. So 7 is the bigger number, so our GCF is equal to 7, okay? All right, so that's just going over what the previous lesson was on. So now let's go down here, and we're just going to practice some dividing and multiplying with variables. So we're going to simplify these. So for the first one, x to the 7th divided by x to the 4th. So I wrote down here that to remember that when we divide variables, we subtract the exponents. But I'm going to just explain, I'm going to show you why, just so you understand what's happening when we do that. So when we see x to the 7th, what that actually means, hang on, okay. All right, so when we see x to the 7th, what that actually means is that we are multiplying x by itself 7 times. So we're seeing x appear 1, 2, 3, 4, 5, 6, 7. Okay? So we have 7 x's. So then x to the 4th means that we have 4 x's. 1, 2, 3, 4. Okay? And now we want to figure out, well, when we divide that, how many are going to be left? Okay? So what's going to happen is this x up here is going to cancel out with this x down here. Then this one and this one, this one and this one, this one and this one. And we're left with 3 x's in the numerator. So the way we write that, if we have 3 x's remaining, is we write x cubed. Okay? Now, you don't need to do this whole thing every time as long as you can remember the rule, which is just that when you're dividing, you always subtract your exponents. So think about it this way, x to the 7th divided by x to the 4th is x to the 7 minus 4, that's supposed to be a 7, which is equal to x cubed, okay? So you don't need to do the whole long thing, I just wanted to show you kind of what was happening there with that, okay? All right, now let's take a look at number 2. Now here we are going to be distributing, so that's multiplying. And here when we multiply, we add our exponents. So the first thing I want to do is actually rewrite this over here because I want to include our invisible 1 exponent. Hang on one second. So this has an invisible 1, okay? And now we've got parentheses x squared plus 7, okay? All right, so now we're going to distribute the x to the first into the x squared plus 7. So first when we do x to the first times x squared, we're going to add our exponents, so that gives us x cubed, okay, plus x to the first times 7, which is going to give us 7x, okay? When they don't have anything, when there's no other variable with the number, you just stick them next to each other. So you can write the answer like this, or you can put the invisible 1 exponent in. Either way, it doesn't really matter because this is our final answer, okay? All right, so what I just showed you here on example number 2, what we're going to be essentially learning today is how to do the opposite of this. So you'd be given this algebraic expression, and we're going to factor it. So we want to basically turn it into that. We want to go the other way, okay? So let's take a look at example number 3. So for the binomial expression 4x plus 4y, we want to start off by finding the GCF. So if you look at the numbers, both of them have 4, okay? So the first part of our GCF, let me just make this a little bit bigger. The first part of our GCF is 4, okay? Now, if you look at the x and the y, those are not like variables, okay? They're not the same. So that means that neither one is going to be a part of the GCF. So the GCF is only going to be, I'm just going to fix this because it looks a little messy, is only going to be 4, okay? So that's the first step to these problems, is we always just start off by identifying the GCF, okay? So now the next step, what would be left over if we divided each term in the expression by the GCF? So I'm going to take my original expression, which is 4x plus 4y. Bear with me, I'm still learning how to write on this thing. Okay. And I'm going to divide each piece by 4, my GCF. Okay. And then I'm going to see, okay, well, what am I left with when I do that? So when I do that, so here the 4s, I know we say cancel out, but really it's reducing to 1. So it equals x plus, and then here they cancel out also, y. Okay, so this is what we get when we divide each one of our pieces by the GCF. So if I wanted to express my original problem in factored form, what that means is that I would write down the GCF, and then in parentheses, I'm going to put what was left when we divided the GCF out. Okay, so that's the idea behind factoring. So this is really our final answer if we were asked to factor. Now down here, I have our definition, breaking down an expression into factors. So the opposite of distribution. Okay, so we're kind of undoing distribution. You can sort of think of it that way, okay? And then just to do a little check, let me just show you something. If, let's say, we wanted to distribute the 4 back in, look, we would get the original problem, 4x plus 4y, okay? So that's a way to check and see, did you do the problem correctly, okay? All right, so now let's go through some examples. And I have up here at the beginning the steps that you can use to do this. So determine the GCF, write the GCF on the outside of the parentheses, divide, and put the quotient inside the parentheses. Now, number 5, check for distribution. I'm not going to make you do that. It's just something that is an option that, would just help you make sure that, you got the right answer. So we really just did number 1 on the previous page. So let's go to number 2. So we want to first get our GCF. So let's list our factors of 6. So 1 and 6, and 2 and 3. And then let's list our factors of 12. So 1 and 12, 2 and 6, 3 and 4. Okay. So now let's identify what numbers both of these lists have in common. So they both have 1, they both have 2, they both have 3, and they both have 6. So the biggest number that they have in common is 6. So our GCF is equal to 6. Okay, so that's our first step. That's step 1. So now we are going to take our original expression, the 6x minus 12y, and we are going to divide each piece by our GCF, which is 6. Okay, so when we do that, so here our 6's cancel out, or really reduce to 1, but we just say cancel out, and we're left with x minus, now the 6 and the 12, if you do 12 divided by 6, that simplifies to 2. So it's x minus 2y. Okay, so that's step 2. We did the division. Okay, and now really all you need to do is write your answer. So to write the answer, we just take our GCF, which is 6, and then put this guy in parentheses. And that's it. That's our answer. Okay, done. All right, so let's take a look at number 3. Okay, and again, guys, this answer key and blank worksheet is on Google Classroom for you to check out. All right, so number 3, we're going to start off the exact same way. We're going to find our GCF between our two numbers. So we've got 15 and 90. Okay, so our factors of 15 are 1 and 15 and 3 and 5. And we've got a whole bunch of factors for 90. We've got 1 and 90, 2 and 45, 3 and 30, 5 and 18, 6 and 15, and 9 and 10. Okay? All right. So big list for 90. All right. So now let's circle what numbers these two lists have in common. So they both have 1, they both have 3, they both have 5, and they both have 15. Okay? So the biggest number that the two lists have is 15. So that's our GCF. Okay? First step, done. All right? So now we are going to take our original expression, our 15a minus 90b, and divide each piece by 15. Okay? So when we do that, here, the 15s cancel out. We're left with a minus. Now, when you do 90 divided by 15 in your calculator, you're going to get 6. So this over here just simplifies to 6. So minus 6, and don't forget the b is still attached to that. So you have to bring the b along with that. Okay? All right. Last step is we're just going to write our answer. So we write the GCF, which is 15, and then in parentheses, we're going to put the a minus 6b, the value we got when we divided. Okay? Alrighty. Okay, let's go to the next page. Only a few more questions. Okay. All right, let's take a look at number 4. So the only difference about number 4 is that now, instead of dealing with a binomial that has 2 pieces, now this question is, a trinomial because there are 3 pieces. So we just need to get the GCF now of 3 numbers instead of 2. This is what we didn't do now. So let's list our factors of 10. So 1 and 10. 2 and 5, and that's it there. Factors of 20, 1 and 20, 2 and 10, 4 and 5. And lastly, our factors of 30, 1 and 30, 2 and 15, 3 and 10, 5 and 6. Okay? All right, so now let's circle what numbers both lists have. All 3 lists have. So everybody's got 1, everybody's got 2, everybody's got 5, and everybody's got 10. Okay, so the biggest number that all 3 lists have is 10. So that is our GCF. Okay? All right, so now let's go back over here, and we're going to divide our original problem by our GCF. So I'm going to divide this each piece by 10, okay? All right, so the 10A over 10, the 10s cancel out. We're left with A plus. Now, 20 divided by 10 is 2, so 2B, minus 30 divided by 10, which is 3, and then C, okay? So we just divided, so this guy reduced to 2, and this guy reduced to 3, okay? So now to write our final answer, we just first write down our GCF, which is 10, and then in parentheses, we put what we got over here, A plus 2B minus 3C. Okay? All right, good. Now, questions number 5 and 6 are a teeny bit different, only because now the GCF is going to be a variable and not a number. So looking at number 5, the first thing I want to do is let's fill in our invisible ones. We have a few of them. So the x squared has an invisible 1 in front, okay, plus 3x, and then that x has an invisible exponent of 1, okay? So now we need to figure out the GCF. So let's first look at our coefficients, our numbers in front. So the GCF between 1 and 3 is just going to be 1, okay? So if one of the numbers in front is just 1, there's not going to be a number really a part of it. Right now, we're focusing more on the variables, okay? So at the beginning of our GCF, you can write 1, because there's nothing else in common with the 1 and the 3. Now, with the x squared and the x to the first, whenever you're doing the GCF of variables, what you always want to do is take whoever has the lower exponent. So between x squared and x to the first, the lower exponent would be this guy here, x to the first. So we're going to tack that on here as part of the GCF. So our GCF right now is 1x to the first. You could also write that as just x to the first or just x. Any one of those would be a correct way of writing it, okay? Now, the steps still continue in the exact same way. So we've got x squared plus 3x. This was our original problem. I'm going to put in my invisible one. And we're going to divide each piece by our GCF, x to the first. Okay, I decided to use this one. It doesn't really matter. So now remember from the beginning of the worksheet, we went over what happens when we are dividing. We want to subtract our exponents. So here we're going to be doing 2 minus 1, and that is just 1. So x to the, first, plus, now for the second one, you have x to the first over x to the first. So when you're dividing, since they're the exact same thing, they just cancel out. So you're left with x to the first plus 3, okay? And now to write our final answer, we put our GCF on the outside, so x to the first, and then in parentheses, x to the first plus 3, okay? Which you could also, if you wrote it like this is also a correct way of writing it, okay? All right, so one more problem, and then we're done. All right, so now on number 6, so again, this one's a little bit different again, because now we have no number. We don't have, the coefficients are both just 1, but now we've got 2 different letters happening. We've got the A's, and then we also have a B. Okay, so let's first focus on just the A's. Okay, that's going to be our first focus. So we've got a to the 4th and a to the 7th. So the GCF is always just going to be whoever is the lower exponent, which is going to be a to the 4th. Okay, now we're going to look at the B. Now here we only have a B in my first part of my binomial. I don't have one with the a to the 7th. So B is not part of the GCF. Okay, so you're not going to tack on anything with the B because it's not in both pieces. Okay, so your GCF is only going to be a to the 4th. Okay, so now I'm going to write my original problem. And we're going to divide each piece by a to the 4th. Okay, so when we do that, so here the a to the 4th and the a to the 4th, since they're the exact same thing, they just cancel out and you're left with b plus, and now here we're going to just subtract our exponents, so 7 minus 4 gives us 3. Okay, so b plus a cubed. Okay, so now to write our final answer, we're going to write down our GCF, which is a to the 4th, and then in parentheses, we're going to put b plus a cubed. Okay, and this is our final answer. All right. Okay, so that goes over the factoring GCF lesson. We're going to be doing more examples like this, and then moving on to be doing more factoring. If you have any questions, contact me through Remind or email, and we will go over whatever you need to. All right, thanks, guys.